All right, so I am covering the slope formula, which is a very important part of linear equations or equations for lines. And just linear equations in general, understanding how to graph lines is very important in a lot of different fields. So this is something that really does touch pretty much any field that someone might be going into. So first, what exactly is slope? So slope is a number that tells you how steep a line is or how slanted a line is. And it also tells you the direction. And direction meaning as you move left to right, is it going up or down? It doesn't tell you an angle. It's not a measurement of angle. It's just a measurement of steepness in terms of your horizontal and vertical distance. So the bigger the number, the steeper the line is. And when you're looking at this, you ignore the sign because a negative slope just gives you direction. So whether it's positive or negative is telling you whether it's moving up or moving down. So if you ignore the sign, the actual number will indicate how steep it is. So a slope of 10 is steeper than a slope of 5. And a slope of negative 10 is steeper than a slope of 5 because you just ignore the sign and you look at the number itself. So slope is a number that tells us steepness, and then it's also a positive or negative, meaning whether it's going to go up or go down. So our equation for slope, we use the letter M, and it's described in many ways. So we have rise over run, which is a very common way to remember slope. It's rise, how much you go up, divided by run, which is how much you're moving over. So that's what rise over run means. It's also defined as the change in y over the change in x. And that's in terms of if you're thinking of your axis, you got x and y. So it's how much you're changing in the y direction divided by how much you're changing in the x value, in the x direction, basically the same as rise over run, just in different words. You can also see it with this triangle symbol here. So the triangle is the Greek symbol delta. So that is a capital delta, is that triangle. And that symbol basically means change in. So it's literally a shortcut. Instead of writing the words change in y, we use that symbol, that triangle, to indicate that it's change. So that delta y over delta x just means change or difference. That's another way that you can look at it, because the amount of change, we're looking at how something changes. We're usually looking at subtraction here. And so that's what gets you your final formula here, y2 minus y1 over x2 minus x1. And that formula is basically telling you that you need to have two ordered pairs, because you have an x and a y, which is the first point, and then an x and a y, which is the second point. So to find slope, you need to have two specific points on your line, and then you can find the slope. So again, ignoring the sign. So if you're just looking at the absolute value of the number, the higher it goes, the bigger it is, the steeper it is. We can get a value of undefined, and this is where your denominator is 0. So if you end up having no change in x, that means you're not moving left or right, you're only moving vertical. So that's a vertical line. And so the slope is undefined because you're dividing by 0, which you can't do. There's also a way to get a slope of 0. And to have that happen, you need to have the top of your fraction be 0. So that means there's no vertical change. So it's only going left to right. And that gives you a horizontal line. And so that means it's not slanted. So having 0 kind of makes sense there. And then you've got, if your slope is greater than 0, that means you're increasing as you go left to right. So just like we read books, everything we do is left to right. When we're looking at lines, we're going left to right. So increasing is that it's going up as you're going left to right. So that's a positive slope. And then a negative slope is when you're going down as you move from left to right. So I have a link here if you want to learn more about the symbol, the M, why it's an M. You can check that out when I send out the PowerPoint. So we're going to be practicing using this formula. That's what we're going to focus on here, is being able to successfully use the formula in order to find the slope between 2 points, or to find the slope of a line. So we'll start with just using the formula between 2 points. So our formula, if I can have the correct color here, is m equals y2 minus y1 over x2 minus x1. So it's always the y over x. And you can think of this as, I think I mentioned this when I'm trying to, when you're trying to remember whether your x is horizontal, you know, and your y is vertical, as I was told y is up, y is vertical. And then if you're looking on the fraction, up is the top of the fraction. So y is on the top of the fraction. So y's up is what I use to kind of remember that it's y over x. And then it's always 2 minus 1. And you have to match it. So you can't have y2 minus y1 and then x1 minus x2. You can't subtract them in 2 different orders. You need to subtract them in the same order. So we got y2 minus y1 over x2 minus x1. So what I do when I have a set of ordered pairs, which are always given x comma y, they're always an alphabetical value, is I label what is x1, what is y1, what is x2, and what is y2. So I just use the first point. So -3 will be x1 and -8 will be y1. And when you're writing this, or even when you're typing this, this is a subscript. When the number is below, that means it's a label. So the 1 is just labeling this, that this is the first point. It's not an exponent. If you put it on top as an exponent, then it's not a label anymore. And you're saying that you're squaring like your x or your y. And that's not what we're doing here. So if you writing it with the number as an exponent would be incorrect. These are subscripts, so they're below. So the second one is x2 and then y2. So 4 is equal to x2 and then 6 is y2. So once you've labeled everything, it's good to just write down the formula. Just so the more you write down the formula, the easier it is to memorize it. So it's good to just write it down. And then you're going to replace your values. So y2 is 6. So I'm going to have 6 minus, and then y1 is a -8. So when you have a negative there, you're going to want to put it in parentheses because we're subtracting a negative, which then is actually adding. But so you don't make any sign errors. You want to make sure that you're actually showing that you're subtracting a negative. Then we've got x2, which is 4 minus x1, which is also negative. So we have a -3 here. So once you've plugged in, oops, somehow change that. Once you've plugged in the numbers, now you're just doing the math. You're just simplifying the right side into figuring out whatever this number is. So we get 6 plus 8 because we're subtracting negative, and 4 plus 3. I really encourage you to turn those subtracting negatives into pluses and write down that step. So that way it's easier to find any possible mistakes you make, and it kind of eliminates any possible errors with your signs. So 6 plus 8 is 14. 4 plus 3 is 12. So we get a fraction 14 over 12. And then we want to reduce our fraction. We don't give it as a decimal unless it's like a word problem. So we need to reduce this fraction, and we can divide both sides by, or not, I shouldn't say both sides, the top and the bottom by 2. And this gives you 7 over 6. So this is a measure of the steepness. It's 7 over 6. So 0 is flat. 7 over 6 is like 1 and a 6. So I think it's like 1.18 something, I think. I don't have my decimal equivalents memorized, but it's a little bit over 1. So if you've got 0 being flat, having a slope that's a little bit over 1 will be slightly slanted, but it's not like super steep, you know, something like this. So it's going to be slanted a bit more. But, you know, if you had like a slope of 10, it'd be way steep. So it's just kind of a little bit slanted there because it's only a little bit above 0. Are there any questions? Okay. So let's take a look at the one on the right where we have fractions, because when you have to find slope between things that are fractions, that can get a little tricky. So again, I'm going to just label x1, y1, x2, and y2. So m is y2 minus y1 over x2 minus x1. So y2 is 1 and y1 is 6. I can just do 1 minus 6. X2 is 5/2 and x1 is 3/4. So the top is easy to simplify. 1 minus 6, we can do that. In the denominator, we've got these fractions, and in order to subtract fractions, you need to get a common denominator. So the common denominator would be 4. So I'm going to multiply the first fraction, not by 4, by 2 to get up to 4. So 1 minus 6 is -5. And then we have 10/4 minus 3/4. So this is going to be -5, and then 10 minus 3 is 7, so we get 7/4. So we have a fraction inside a fraction. Now, fraction means division. So what this is actually saying is that we have -5 divided by 7/4. So we're dividing by a fraction, which means you're multiplying by the reciprocal. So this is really the same as -5 times 4/7. And this is how you simplify something like this. So in order to kind of multiply these fractions, I need to write my -5/1 to make it a fraction. And then what I do is I try to reduce before I multiply, but there's nothing to reduce here. 7 doesn't have anything in common with 7 or 4, so we can just multiply these. So we get -5 times 4, so that is a -20. And then 1 times 7 is 7. And they don't have anything in common, so that is the slope. So in this case, we have a negative slope. So 0 is here. Negative means we're going down. And then it's at least 2. It's steeper than the other one because it's a -2 and something. I don't, I'd have to convert it to a mixed number to know exactly, or put it on my calculator to find the decimal value, but it's steeper than the other line that we have. So what I'm going to do is pull up Desmos just to kind of give you an idea of what a slope like these look like. Okay, so first thing, I'm going to type in -3, -8, and then 4 and 6. Actually, what I should do is not do it this way. I'm going to do it in a table. -3, -8, 4, 6. Okay. When I do it in a table, I can actually connect them with a line. So I can, this is when you draw a line through those 2 points, this is what it's going to look like. So this is a slope of 7/6. This is what this looks like. So 0, slope of 0 is here. This is 7/6. Our other line has 3/4, 6, oops, 6, and then 5/2, 1. So this other line, so it's in a different location. So You know, we're not going through the same point. We've got two different lines, but this has a negative slope. So you can see that our second line, negative, means it's going down. So the first line is positive, so it's going up as you move from left to right. The second line is a negative slope. It's going down as you move from left to right. And this slope is steeper. So it might be kind of hard to visualize, but if you look at around here, you can kind of see if you were to draw a triangle or kind of draw a triangle here, because they're kind of near, pretty much sort of in the same spots here. Let's try, I think I can do, I think this is what I want, where I can draw it, draw on it. So if I kind of make a triangle here to kind of give you an idea of the steepness between here. So we've got one triangle, the purple, the negative slope looks like that. The other triangle, if I try to make it in about the same spot, you can see it's wider, so it's not as steep. You know, if you're kind of comparing the angles, it's a lot, the purple is a lot steeper because the angle is tighter there than versus the other one where the angle is a little bit wider. So the number for our second slope here, the negative 20 over 7, is steeper than the first slope. We got 7 over 6. They're in opposite directions. One's going up, one's going down, but you can kind of compare the steepness just comparing with the numbers. Are there any questions? Okay. So let's look at what happens if you're given a line. So an equation for a line is a line that goes on forever. So we've got these arrows here that indicates that it kind of goes forever. When you're trying to find a slope for something like this, you're not given the ordered pairs, and you need the ordered pairs to find the equation. So what you want to do is actually read ordered pairs off of your graph and then use the formula, or you can use the idea of rise over run to kind of do it that way. So it kind of depends, you know, what the order pairs are, but you want to try to pick points that are easy to read off of your graph where you don't have to estimate. So you want to kind of pick them on the grid, because then you're not dealing with, okay, is this like a 1.8 versus a 2? So the graph here on the left, we could pick this point because it's on a grid line, or we can pick this point, or this point, or this point. Like any of these points would be perfectly fine to pick because they're all on the grid and easy to read. So you can pick any number you want to kind of find the slope between them. And I could, you know, pick this point and this one if I wanted. It doesn't matter. You'll get the same slope either way. So it doesn't matter which pair of points you pick, as you'll get the same answer. And if you don't, that means you messed up. So normally if there's more than one person at the live, I would have multiple people doing different, you know, picking different pairs, and then we'd compare that we all get the same slope, but we don't have that here. So I try to pick easy numbers. So I'm going to pick this one right here, which is 0, 1. And then this one looks easy enough, which is 2, 2. So you have to be able to read your graph. It's always x comma y. So the first one is 0 on the x and 1 on the y. And then the other one is 2, 2. So our slope formula, let me give that formula again in the correct color. Equals y2 minus y1 over x2 minus x1. So x1, I'm going to label 0, y1 will be 1, then x2 will be 2, and y2 will be 2. So my slope is And I'm not going to rewrite the formula this time just for interest of space. So y2 is 2 minus y1, which is 1. Then we have x2, which is also 2 minus x1, which is 0. So 2 minus 1 is 1, 2 minus 0 is 0, and we get a slope of 1/2. What this means is if you're thinking this in terms of rise over run, it's rise and run. What this means is you're going up 1 unit, that's the rise, and then over 2 units, and that gets you another point on the line. And you notice this pattern, all of these points that I picked, if I go up 1 and over 2, I'm going to land back on the line. So that's what rise over run means, is how much you go up, how much you go over, and you'll be on your line again. Up, over. And it kind of, when you're drawing your little triangles here, the rise over run, you get like stair steps, but you're always landing back on that line. And that's really what the slope kind of is. It's a ratio between your upward and your over your horizontal distance. And so every point on that line is going to have the same ratio. They're all kind of following at that pace. So if we look at the one on the right, we want to pick easy points. So I've got this 0, 3. And the next easy point looks like 1, -1. And then I don't like to pick the endpoints of the arrows because it's kind of hard to tell. So I don't know if this is right here or not. It looks like it, but I don't like to pick those just to be safe. So there's really only 2 choices here for points that we can pick, because otherwise we have to kind of guess at, is this a 1/2, and you want to avoid guessing what your order pairs are, because then if you guess wrong, your slope's going to be wrong. So you want to pick ones that basically look like they're, on your grid. So the first point I have here is 0, 3. 0 on the X, 3 on the Y. And then I have 1, -1. So that's 1 on the X and then -1 on the Y. So again, I'm going to label these X1, Y1, and X2, Y2. And then we're going to plug them into the formula. So Y2 is a -1 minus Y1, which is 3. And then X2 is a 1 minus X1, which is 0. So we get -1 minus 3, which is -4. 1 minus 0 is 1. And -4 divided by 1 is just -4. So this is a slope of -4. So you can see that the graph we had on the left had a positive slope. The graph on the right is a negative slope. So you can see they're going in opposite directions. And here you can really see the steepness. The slope of 1/2, which is close to 1, it's definitely flatter than the slope of -4. That 4 is much larger, so it's a much steeper slope. Any questions? Okay. So I want to do a few horizontal, not a few, 2. We got one of each, a horizontal and vertical line, just to kind of show you what slope means in those cases. And, how. So first off, you kind of want to memorize that when you have a horizontal line, you want to memorize that the slope is 0. But you can figure that out just by thinking slope is steepness. This is not steep, it's flat, it's not going anywhere. But you can also do it by picking points. So let's say I'm just going to pick 2 random points here. Let's say I have -2, -4. And then my other ordered pair I picked was 3, -4. So I'm going to label them X1, Y1, X2, Y2, and use our formula. So again, I'm going to write down m equals y2 minus y1 over x2 minus x1. So y2 is a -4 minus y1, so that's also a -4. So I have a -4 minus -4. And then x2 is 3, and x1 is -2. So when you subtract a negative, you're adding, so this is -4 plus 4, and then 3 plus 2. So -4 plus 4 is 0, 3 plus 2 of 5, and 0 divided by anything is 0. So we get a slope of 0. So if you don't have memorized that a horizontal line has a slope of 0, you can find it, but it's much faster to look at it, say, oh, this is horizontal, my slope is 0. You don't have to do any of that work. Now let's take a look at our vertical line here. So the thing is, when you have vertical lines, your slope is undefined. It's literally the word undefined. It is not infinity. We write undefined because there is no definition for kind of what it would be when you divide by 0. So you can still pick 2 ordered pairs if you're trying to figure this out. Now, in this case, we are going to have to estimate where the x value is, but at least we're using the same x value in either side, so it won't matter. It looks to be at about 1/2, 1.5. So I'm going to just use decimal points for this to make it easier. So it looks like it's at 1.5 on x. And then I've got 1 point that's at 2. And then the other one is at 1.5 and looks like it's at a -2. So you can pick any 2 points on that line. And so I've got x1, y1, x2, y2. It's a terrible x. So our slope m equals, so it's y2, so it's -2 minus y1, so that's -2. And then x2, which is 1.5, minus x1, which is also 1.5. So -2 minus 2 is a -4. 1.5 minus 1.5 is 0. And see, this is where we're dividing by 0, because the change in the x basically canceled, and dividing by 0 is undefined. So that's why your slope is undefined here for vertical lines. But it's a lot easier if you memorize that, or you don't have to memorize, you can have like a note card or something where you have this written down, but horizontal lines have a slope of 0, vertical lines have a slope of undefined. Or any questions? Okay, so I've got one last example of slope and kind of using the formula and what it means. So this is sort of a thinking kind of problem. So we're given a slope in this case. Use the slope m equals -2 and the point 0, -9 to find 3 additional points through which the line passes. So this is where we're using the definition of slope being rise over run. That's at least what I use, rise over run, or change in y over change in x. So I use that definition when I'm doing a problem like this. So we're given that our slope is -2. So -2 is equal to rise over run. And if you write -2 as a fraction, you would put it over 1. So that would be -2 over 1 equals rise over run. And this is essentially a proportion. What this is saying is that our rise is -2, which negative means instead of going up, you're going down. So we're going down by 2. And then the run is 1. So we're going over 1. If you had a negative there, you would go in the other direction. So I use this with our ordered pair to create more points. So we have our ordered pair 0, -9. And I'm just going to label that this is X and then Y. And your rise over run is Y over X. So for Y, we have a -2. So you're subtracting 2 from your Y value. And then X, we've got a 1. So we're adding 1 to the Y value or to the X value. And that gives you a second ordered pair. So that will give you 1. And then -9 minus 2 is -11. So you have another point. So point, if we call this point number 1, we now have point number 2. We just got a second point using that slope. And then to get us another point, you can do it again. You just repeat the process. So I add 1 to the X, I subtract 2 from Y, and this will give me, let's see, do I want to change color or not? I guess I'll just stick with the same color. 1 plus 1 is 2, -11 minus 2 is -13, and now we have another point, point number 3. So we want 3 additional points, which is going to give us a total of 4 points. So again, I'm going to repeat the process another time. And this gives us 3 and then -15. It gives us a 4th point here. And you can do this an infinite number of times. You can use this slope to just keep generating ordered pairs on this line that has this slope. So it's a lot like the stair step that I showed, the rise and the run where you get a new point. We're using that process to get to another point on the line. We're just, instead of having a graph, we're doing it literally off of the numbers. And you can check your work by finding the slope between any of these points. Like if you found the slope between point 4 and point number 1, you will get a slope of -2. So you can check your work, and let's just do that here. So I will use point number 4 and then point number 1. So point number 4, our Y value is -15. And for point number 1, the Y value is -9. And then we've got an X value of 3 and then X value of 0. So -15 minus a -9 is -15 plus 9. I'm going to I don't have a lot of space here, so I'm just going to do that. So that gives us -6. 3 minus 0 is 0, or is 3. And then -6 divided by 3 is -2. So we got our slope of -2. So you can check and make sure that your points that you're generating do have the same slope. Another way to check that you're doing this correctly is after you've checked that they do have the correct slope, is to check that if you connected them all, they do have a line. Because if you made a mistake, then there wouldn't quite be a line between them. So if I go back to Desmos, and I'm going to use the table with the values that we have here. So I've got 0, -9, and then I generated 1, -11, 2, -13, and 3, -15. I'm going to have to kind of move down here. So when I connect these, they do form a line. If I had messed up my math and maybe got like -14 here, or -14, you would see that it doesn't exactly form a line. Something's different there, and that would indicate that you messed up. So a good way to check that you're doing a problem like this correctly is to graph your points and draw a line between them and make sure they're all on the same line. And then if they are, calculate the slope between a pair of them to make sure it's the correct slope. And then that's how you can check your work to make sure that you correctly have points that have this slope when you connect them. But you can do this, you just follow the pattern, and you can go the pattern in the other direction. So instead of adding 1 and minus 2, I could subtract 1 and add 2. So if I subtracted 1 from 0, that would be -1. And if I added 2 to -9, that would be -7. So I can go in the other direction here and keep subtracting 1 and adding 2. And that just keeps getting other lines, other points on this line. It's just extending our line. So you can put your sign, your negative sign in either direction. You can flip the signs there, and it just kind of works backwards versus going forwards. So are there any questions? All right. So that's basically how you use the slope formula and what slope is. There's so much more we can do with slope involving equations of lines, where you can find the equation of a line once you know the slope. There's a type of equation called slope-intercept form. There's also point-slope form. So slope is very important for those types of problems where you're trying to get an equation of a line, or you can have an equation and get the slope from it. But this is slope, like the concept of slope, what it actually means, and kind of working with that formula. So glad that this is helpful. And we've got one more live after this because it's week 7. So is it week 7? No, it's week 6. No, week 7. Week 7 started. I'm grading week 6. So yeah, we've got only one more live, and then it's the end of the term. So we really are finishing up, and comes very quickly. So I thank you so much for coming today.